Lesson 7.5, Parametric Equations. Before I get started, I know you can read this, but I want to just kind of walk through what a parametric equation is. Parametric equation is our way in mathematics of measuring something that's in flight. So for example, a projectile that might be shot up in the air would be moving over time. So it would be making a path like this. Now, at any one time, normally in the past, when we typed in a graph to the calculator, you've seen the whole graph. It might be a whole parabola if you shot something up in the air because gravity would pull it down. But what parametric equations do is it measures it over time. So it might say that at 1 second, maybe it was right there. At 2 seconds, maybe it was right here. At 3 seconds, here. 4 seconds, here. Because you start to learn things about that. Projectiles, when they're sent up, they'll slow down at certain points, and then they'll start speeding up because of gravity again. And so our parametric equations will just kind of go like this. And so this graph would just keep moving on over time, and we could keep tracking it if we wanted to. Now, here's one thing that busts out in this is the calculator won't stop it at the ground. So most of our applications, we're just going to go until the x-axis. That'll refer to hitting the ground. But to measure, what we have to do is introduce a third variable. You'll have your x value, which x is typically going to be distance. Typically, not always, but typically. The y would be the height of an object. Again, this is typical, not always. And then there's that third element that I was listing here in blue. There's going to be t, which will stand for time. So how do we solve with three variables? Well, we're going to break up the x and y and treat them separately. So here, let's look at the first equation here. It says sketch this curve given an x equation and a y equation with the variable being t. That's time. And it gives, we want to have from -3 seconds to +3 seconds. Now what I'm going to do is show you how to use a calculator for this. So if we go to our calculator, what we're going to do is go open up a graph. Now in graph, we're going to do the same thing we did with conic sections. We're going to press menu, go to graph entry, and we're going to choose, but this time instead of going to equation for conic sections, we're going to choose parametric. This will automatically change the calculator where it has two functions, an x function and a y function, and they're functions of t. So we do type it in as with the variable t. So we have t squared minus 1 for the x, t squared minus 1, and then the y equation was t divided by 4. It was t over 4, and then I forget what after it, t over 4 plus 2. Okay, and then you go down here and you type in your t value. So we wanted to look from -3 seconds. So I'm going to put -3 here on the left of t, and then you're going to put +3 on the right of t. This will tell the calculator like what seconds to look at. Now this t step is just how often the calculator will refresh. So it's going to kind of refresh a tenth, just basically about a tenth of every second. So here's our graph. I want to show you this, and we're going to pay attention to it for a second. Because what I could show you is this is the time at the start, and it's moving up this way. Now, how do I know that? It's because if you go to menu and click trace and graph trace, it'll show you the x value, the y value at any one point. It'll also show you the time. As I press right, right always takes you forward in time. It doesn't mean it'll go to the right on the graph. It just means it'll go forward in time. So as I press right, you'll see that the time value down here is only going to increase. So right now it's -4. If I keep pressing right, -1.4, sorry. You'll see it starts working its way toward the positive, and then it starts making its way positive. This, the vertex of this parabola happens to be when time equals 0. That's not always the case, but many times it is. What's also neat about it is you can see it's shifted left 1 and up 2. Well, if you go to your equation on the x, we have a -1 here. Notice it's not in parentheses with x, so we would treat it normal. So this would be saying left 1. This one would be saying up 2, again, because it's not in parentheses with y, so it's not backwards, it's normal. So that's just some ideas. Now, I'm going to show you one thing also. I could go back up to that equation, and let's say I change the time. If I start the starting time at time 0, now we'll start at the vertex of that parabola, and maybe I want to put 5 seconds here. This means it'll continue on the right longer. So as you can see, now I started here at -1, 2, and it's going to continue on a lot longer, and you can see it's picking up speed. It's going a lot faster. How do I know? Because it extended way out there. Before, we had 6 seconds we looked at from -3 to +3, and it was a parabola just like right in here. Now we're only looking at 5 seconds from 0 to 5, but you can see it's a lot longer because it's picking up speed. as it goes. Again, if you want to know that, you could go to trace and graph trace it, and you can see the values. As you go right, you can see it's not moving very fast. Here the value is at 1 second. It's about at the y-axis. As you continue on, you'll see it picks up the pace and it starts moving. It jumps a lot further as you go forward in time. So that's part A, and here was the graph. Now let's look at part B. So this time we're going to change the equation. We're going to look at this. And I forgot to point this out in this last one. This was a horizontal parabola because the t squared, the highest power, was with the x. And t squared looks like a parabola. So since the highest power is with x, it's horizontal. Typically, the highest power tells you the shape. The lowest power tells you the direction. Since this is positive here, it wasn't a negative t. Since it was positive t, it was moving up. So in this one, we can make some assumptions. Again, this is the highest power. So we can assume since squared makes a parabola, it's going to be a horizontal parabola. And since this is positive, it should be moving up again. Let's go back and check. So our first equation now, I'm going to zoom standard this to get it back up to the origin. Now I'm going to press tab to change my equation. The equation is now a fraction. It was t squared. Let me go back here. Control T. Okay. I want a fraction. It was t squared over 4 minus 1. So again, we should be shifted left 1 unit, we would assume. And on the bottom, it was t over 5. And it was shifted up 2. Again, we're at assume. Sometimes it can be thrown off a little bit, but we'll get there. And so here's my other graph. Oh, and I forgot to change the time. Let's go back and look at the time that it automatically does from 0 to 2 pi. That 6.28 is 2 pi. That's the automatic standard settings, but they want it from -5 to 5. So we need to change that. So put -5, +5 seconds. So here's our parabola this time. And you can see again, they have the same origin, but this time from -5 to 5. So this is slower moving because, remember how I told you this is the direction? The lower power is the direction. It's the time divided by 5. So it's going to be slower moving than this one up here where it was time divided by 4. Let's press trace, menu, trace, graph trace, and we want to trace the other graph, which, let me go here, let me press tab, I'm going to turn off the first so I can trace the proper graph. Okay, so now menu, trace, graph trace. Again, as I go forward in time, you can see it's going up. And it's going up because this lower power is positive. That's why the graph looks like that. Here's their picture. These arrows represent the flight of the object, which way it's moving, and these dots are representing the whole second. So that's where it is at -5. This is its location at -3, -1, 0, 1, 3, 5. Now, I've got one for you to try. And there's a way of doing this into Desmos. What we'll do is, if you need to do it on Desmos, is you'll do it at like a coordinate point. So I just open it up, I'll show you. So let's say our equation was here. You have 2t minus 6 and t squared minus 3. What you would do is on Desmos, you list it as a coordinate point. So you do parentheses, and then instead of saying x equals, it's going to look for the x first. And so you would do your, I think it was 2t minus 3 or something like that. Let me go back to it. 2t minus 6. And so you do 2t minus 6, and then you do a comma, and then you put in the other equation, which would be t squared minus 3. And I messed up my parentheses here. Let me go back and fix this. Delete the parentheses there. Okay, so now it has it. Then underneath, you would state what values of time you want. As you can see, it's starting to graph it over here. You just need to change the time.